For section 3.4, we're going to be looking at solving linear inequalities when they're in two variables. Our steps to solving these linear inequalities are pretty simple. When you've got something in two variables, the very first thing you want to do is to graph the line. So once it's in two variables, graph the line. Act like there's an equal sign and just graph it like normal, whether it's slope-intercept or standard. Keep in mind that if it's not underlined, if your inequality symbol is not underlined, you need to dash your line. If it is underlined, you need to use a solid line. That's similar to our parentheses and brackets or our open circle, closed circle. Step 2, you're going to choose a test point. 0, 0 is the easiest to choose, and you're going to test it. You're going to actually plug it in and see if it works or not. If it works, you're going to go ahead and shade it. If it fails, you're going to shade the other side of the line, and we're going to talk about that in just a second. All right, for our first example that I've got here, I've got 3x plus 2y is greater than or equal to 6. Now this is written in standard form. Since the x and y are together on the left side, this is written in standard form. And we know when things are written in standard form that we need to use a specific t-chart. We need to find our intercepts by getting a 0. If I plug a 0 in for x, my x cancels, and I'm left with 2y is greater than or equal to 6, or y is greater than or equal to 3. So 0, 3 happens to be my y-intercept for this graph. Now, if I plug a 0 in for y, it's going to be 3x, and the y is going to cancel greater than or equal to 6. Divide that 3 over, and I'm going to get a 2. So x is greater than or equal to 2, meaning my x-intercept is 2, 0. Now, because this inequality symbol in the original problem was underlined, this line, when I graph it, is going to be a solid. It's not going to be dashed. And for the sake of this problem, I'm not going to use my straight edge, although my expectations are for you to use your straight edge. So now that I've graphed my line, we need to find out what my solution is. Well, you got to remember, when you have an inequality, a greater than or less than, you have a lot of correct answers. For example, if you had x is greater than 5, all your right answers or correct answer would be any number greater than 5, 6, 7, 8, 9, on and on and on. Your answers are either all of these points or all of these points. So either every one of these points above the line is going to work in this equation, or every point below the line is going to work in this equation. And the way that you test that is you use a test point, and 0, 0 happens to be the easiest. So what you do is you take the point 0, 0, and you actually plug it into the original equation. So you plug a 0 in for x, and you plug a 0 in for y. These both cancel out, giving you 0 is greater than or equal to 6. Is 0 greater than or equal to 6? No, it's not, which means 0, 0 failed. 0, 0 did not work. And since 0, 0 failed, everything on the bottom of this graph is going to fail, which means everything on the other side of the graph is going to work. So that means your answer happens to be every one of these points. And that is your final answer. Now I want to take a minute and look at a compound inequality. We talked about compound inequalities in your last section. Now we're going to talk about compound inequalities in two variables. What we've got here actually is two separate equations. Both of them need to be graphed. Both of them need to be shaded. The question is, where's our answer? Well, if you remember, when you have an and inequality, your answer is where the shadings overlap. And it's going to be the same case in this graph. It's going to be the answer where the shadings overlap. Now, the way that I want you to do this is I want you to do one equation first by itself, graph it and shade it. The second equation by itself, second, graph it and shade it. Your answer is going to be where those colors overlap. So let's go ahead and look at our first equation. Our first equation is written in standard form. So once again, just like the last one, we know that we're going to be using a specific t-chart, x is 0, y is 0. When we plug a 0 in for x, that x cancels, and I end up getting 5/4 or 1 1/4 for my y. When I plug in a 0 for y, the y cancels, and I end up with x is 5/2 or 2 1/2 for my x. So when I come over here to graph that, I'm going to graph 0 and 1 1/4. So I'm kind of going to guess where 1 1/4 is going to be. It's going to be about right there. When I guess my 2 1/2, I'm going to go about to 2 1/2 and 0. So this is going to be as close as I can possibly get it. Now, if you look at my original equation, this is not underlined. And because this is not underlined, this needs to be a dashed line when I graph this. So if you watch, I'm going to actually dash my line as I'm graphing it. It's the same thing as an open circle, basically. Now I need to know what side to shade. And the way that we determine what side to shade is we come back here in the original problem when we plug in our test point. Remember, our test point is 0, 0. We plug in a 0 for x, we plug in a 0 for y. And what happens is the 2x and the 4y both cancel, giving me 0 is greater than 5. Well, is 0 greater than 5? No, 0 is not greater than 5, which means that 0, 0 failed, which means anything on this side with 0, 0 is going to fail. It means everything up here is going to work. Now I'm going to shade that lightly and not very seriously because I'm going to graph something directly on top of it. Now let's look at our second graph. And for our second graph, I'm actually going to change my color to bright blue. For our second graph, we've got y is less than x minus 1. This is slope-intercept form. We need to start at our -1 or our y-intercept, so we go down here to a -1, and then we're going to move our slope. Well, this happens to be a 1x, making my slope a positive 1. So we're going to go up 1 over 1, up 1 over 1 as many times as we need to. This is not underlined, and because this is not underlined, this line is also going to be dashed. So if you watch when I graph this, I'm going to dash it all the way through. Once again, I need to test the point 0, 0. So the point 0, 0, according to the blue line, is on the left side. So I'm going to come into my equation, I'm going to plug a 0 in for y, I'm going to plug a 0 in for x, and I'm going to get 0 is less than -1. 0 is not smaller than -1. It is not less than -1, which means everything on the side of 0, 0 of my blue line, everything on the side failed. Everything on the other side happens to be a solution. Once again, I'm going to shade it, but I'm going to shade it lightly and not so seriously. Your answer is where those shadings overlap. In other words, your answer is right here in this itty-bitty triangle. What does that mean? It means every one of these points in this teeny tiny triangle will work in this equation and in this equation, both. It'll work in both of those equations if you would plug it in. So your solution is every one of these. Now you need to make sure to shade this really dark, really serious, make it really obvious that that's your answer. For our last and final problem, let's look at graphing an OR. Now remember, for an OR, it's a compound inequality, just like our last one. We've actually got two different equations that we need to graph and shade, and graph and shade. But for an OR problem, it's a little bit different. If you guys remember when we talked about compound inequalities last chapter, for an OR problem, you actually take all of the shading. It doesn't matter where it overlaps or where it doesn't overlap. You take everything that's shaded. So let's go ahead and graph these separately. Let me look at number 1. For number 1, it's in standard form, so I'm going to go ahead and set up my t-chart with my zeros where they belong. If I plug a 0 in for x, I get -3y is less than 21, or y is less than -7. Excuse me, y is greater than -7. I need to flip my sign because I divided by a -3. So I've got 0, -7 as one of my intercepts. Now I'm going to plug a 0 in for y, plug a 0 in for y, the y's cancel, and you get x is less than 3. So 3, 0 is my other intercept. Now this, in the original problem, is not underlined, so that means my line is going to be dashed. So if you watch as I'm graphing it over here, I'm going to be dashing my line. And we need to test it and shade it before we graph the other one. And we always test the point 0, 0. So if I plug a 0 in for x, it cancels. A 0 in for y, it cancels. And I'm left with 0 is less than 21. Well, guess what? 0 is less than 21. In other words, the 0, 0 worked. So everything on the side with the 0, 0 is going to work. Now let's look at our second line. Over here we've got, and I'm going to do a different color. I'm going to do bright blue again. Over here we've got x is greater than or equal to 2. I'm looking at that and I'm noticing right away my y is missing. And the minute we notice one of the variables is missing, I know that's either vertical or horizontal. Where does x equal 2? X equals 2 right here on my graph. And x equals always happens to be a vertical line. Now in this case I'm going to draw it solid because my greater than and less than sign is underlined. I still need to do a test point, even though that's a vertical line. I'm going to test 0, 0. In this case, there's only one 0 to plug in. I just plug it in for the x that's given, and I get 0 is greater than 2. Well, 0 is not greater than 2. So everything on the left of that blue line fails, but everything on the right of that blue line passes. Now I'm going to go back in. I'm going to change my colors back to a green. Remember, for an OR inequality, I don't care where they overlap. Everything that is shaded becomes part of my answer. So everything in this area becomes part of my answer. In other words, the only part of my answer that's not a solution would be any of these points. None of these points would actually work in either this equation or this equation, so it becomes none of my answer.